Laurent series. Hello everyone. In this video we're gonna discuss Laurent series representation of functions. Before starting our discussion, let's see power series representation of complex function. When we deal with complex function, we get power series representation of functions. It's represented by the summation of n runs from 1 to infinity, an into z minus a n. Then the power series representation will be this. When we substitute in the place of n0, a0 means that a0 into z minus 8 the power of 0 means any number the power of 0 is 1. Just so when we multiply a0 by 1, it gives a0, and we substitute number 1, we get this. When we substitute in terms of n2, we get this, and this become a power series representation. Based on this concept, we're gonna define Laurent series. Laurent series theorem says that suppose we have analytic function f inside annulus formed by the centric circle c1 and c2, having center at a with radii r and capital R respectively, where r less than r. Here is a diagram which represents this concept. Then f has series representation with annulus between c1 and c2. Okay, it is given by power series representation an into z minus a raised to n, but here an means 1 over n f n derivative at a over n factorial. We have varieties of list of power series which are frequently used in many situations for evaluation of Laurent series. Here is a raised to z. A raised to z means the power series representation of if we have given function a raised to z, then it will be the summation of n runs from 0 to infinity, z raised to n over n factorial. It becomes, when we substitute here 0, any number the power of 0 is 1. 1 over n factorial means 1 factorial is 1, so it becomes 1 here. Let's continue. If we substitute the n is equal to 2, it will n is equal to 1. Any number the power of 1 is itself, so z over 1 factorial is 1, so it becomes z. When we substitute 2, it becomes z square over 2 factorial is just 2. When we substitute 3 and so on, so a raised to z is equal to the summation of n runs from 0 to infinity, z raised to n over n factorial. Okay, here are different function representation of power series which are used for evaluation of Laurent series. So if we have given 1 over z, we have a power series representation of this formula, summation of n runs from 0 to infinity, z raised to n. It becomes, when you substitute 0, it becomes 1. When substitute 1, it becomes just z. When you substitute n is equal to 2, it becomes z square, so z cube, z raised to 4, and etc. Okay, another one is sine z. Sine z, if we have given sine function or trigonometric function in terms of complex number, it becomes minus 1 the power of n. This is the representation of sine, just here also in cosine. Then when it is z, we use the formula of odd numbers is equal to 2n plus 1, and when it is cosine, we use the formula for even numbers 2n, and we divide it by 2n factorial. Okay, these are different representation. Again, we have hyperbolic function. Sine hyperbolic z means just we eliminate here minus 1 the power of n in both sine and cosine hyperbolic series representation, power series representation of complex number. Then by using these terms, this essential power series representation, we can evaluate Laurent series about singularity points for any function. Here let's see one example. Here, for example, find the Laurent series about their singularity points. Here are given function f of z is equal to cosine of z over z raised to 4. Here cos z means, we know that in the above formula, the formula for power series representation of cosine of z is the summation of n runs from 0 to infinity minus 1 raised to n, then what, z raised to twice of n. It is even because cosine function is even function over what, n factorials to n factorials. So it becomes this is a cosine. So you have to evaluate, you have to find the power series representation separately, and then in the combination for the given function, then you can find the Laurent series representation based on the above formulas. So here we have cosine z power series representation, and again we have z raised to 4. So we have to do is to divide this one by what, z raised to 4. It gives us this formula. So this is the final answer, is the Laurent series about the singularity point of this function. By similar procedure we can do similar examples. Okay, let's see another example. For example, b. Here f of z is equal to z cube e raised to 1 over z. So what is the Laurent series representation for this function about it is singularity points? So here we have general formula for a raised to z. We know that a raised to z means here 1 plus z plus z square over 2 factorial, z cube over 3 factorial, and etc. So by using this concept we can derive Laurent series formula for this one. Okay, and multiply it by what, z cube. Then we got a Laurent series representation for this function. So e raised to z means, as we know in the above concept, this one. So e raised to 1 over z means the summation of what, z raised to n over n factorial. So we have just 1 over z 2 factorial times z square 3 factorial times z cube. This is the power series representation for this one. Then we multiply it by z cube, we get this one, and this is the final answer for our problem. Okay, by using these basic concepts you can solve varieties of function about their singularity points based on concept of power series representation. So in this video we have seen that power series representation of complex numbers and their Laurent series derivation. So in next video we will see another interesting topics in calculus and in mathematics and in all other subjects. Keep in touch with us, subscribe our channel. Thank you so much.